Here, I'll show you how to do the analysis for item number 3 in Stats Assignment 4. So I have the data set open here, and if we take a look at the variable view, we can see that this is a scale measure. It's not categorical. We might also call this continuous data of weight, but we don't know whether it's in pounds or what the unit is, so that hasn't been defined for us. So the instructions tell us to go to the Analysis tab. Frequencies are a type of descriptive statistic, so we select frequencies as we are instructed to do so, and there's only one variable. So we slide that over as something to be analyzed. Notice by default we're requesting a frequency table, so we'll just leave this on to see what it gives us. And then the statistics that are specified are that of the mean, standard deviation, median mode, the range, and usually when I request a range I also want to see the minimum and the maximum values, so I'm going to click those as well. And then we want to understand skewness and kurtosis. So I think we have everything checked that we need. So we click continue. But we're also asked to produce a histogram, and we know that that's a chart. So we'll go here. We'll select histogram. I think it's helpful to include that normal curve so we can compare the curve of our data to what would be thought of as a classic normal curve. And now we're ready to run the analysis. So let's take a look at this table to see what it's telling us. And I would encourage you, when you run your analysis, to go to Kim and Mallory and use the glossary to look up the meaning of the terms that you're generating. Because yes, you can create these values, you can ask for these values, or sometimes you can ask for what we think of as estimates when we're doing inferential statistics, but it's the meaning of what the numbers, it's the meaning of the numbers that's important to think about. So I'm sure you're aware that the mean is basically the average value, and the standard deviation of the mean is the average amount that these data values will vary from the mean. So it's a measure of variance. If your data varies more, the standard deviation will be greater. If it varies less, the standard deviation will be smaller. Median is simply the middle value. If you stacked up all these values and picked the middle value, that's the median. And the mode is the most frequent value. And you can see that it says there are multiple modes that exist. And we can see that when we go down here and see and look at the frequencies. The highest frequency we see is 3, but we see it multiple times. And so that's why they say that the mode occurs more, is for more than one value. Skewness and kurtosis pertain to whether the data is normal, and we'll talk about that when we look at our histogram. And then finally, the range is the difference between the smallest and the largest value, and so you can see that here by requesting them. The smallest weight is 80 and the largest weight is 200, and that's the difference between the two. So let's take a look at that histogram to assess normality. And when we look here, notice that it also gives us the mean and standard deviation by default. It tells us how many cases there were. But we see that we've got this flatness of our data. It's flatter at the top here than this normal curve. And so the flatness of the data pertains to kurtosis. And kurtosis is over, or it's larger than -1, slightly larger. And -1 plus 1 were the values in your textbook for data that might exceed what we think of as normal. Although on October 10th in class, in the PowerPoint, I also cited references suggesting that even though we like to see values between -1 and +1, we consider data acceptably normal for analysis if it's between -2 and +2. So we would consider this data to be normal for the purposes of doing an inferential data analysis, for which one of the requirements was having normal data.